During World War II, in desperate times, the Allies worked on animal-controlled weapons designs. In this film, we're exploring 3 of the most unusual weapons piloted or carried by pigeons, bats, and dogs. No animals were hurt in the production of this film. My name's David Webb, and this is Blue Pauperin. This is the Pigeon-Guided Glider Bomb, the world's first bomb designed to be piloted by birds. It was funded by the US towards the end of World War II and planned as a bold experiment to get around the technological shortcomings of radio and radar systems of the day. We'll break down the bomb's guidance system and explore whether the weapon was truly more reliable than electronic systems, as claimed. The Pigeon bomb was envisioned to be a variant of the Special Weapons Ordnance Device, or SWOD Mark 7 Guided Glider Bomb, ironically known as the Pelican. The main difference was the nose, which was specifically designed to house a pigeon-guided guidance system. The Pigeon bomb was constructed from molded plywood and measured just over 8 foot 4 inches long and had a wingspan of 8 feet 4 inches. It was composed from 4 main sections: the nose section with the guidance system, the center section with the explosive material, the wing section, and the tail section. The fuselage was a streamlined, elongated shell with a circular cross-section hinged along its midline. The shell opened to allow access to the flight control equipment housed in the side. 2 suspension shackles on the upper surface secured the bomb to the plane that would deliver the device to the target area. The wing assembly consisted of 2 main panels mounted directly to the fuselage. The wings used an NACA 0015 symmetric airfoil with identical curvature on both upper and lower surfaces. This assembly was most suitable for frequent pitch adjustments for an unstable glider controlled by birds. Each wing was equipped with elevons, the glider's only flight control surfaces. The tail section used a twin-tail design and consisted of a horizontal stabilizer flanked by 2 vertical stabilizers. The assembly measured just under 5 feet 4 inches in length. Attached to the tip of the fuselage was the nose cone, housing the guidance system. It was controlled by 3 pigeons, whose task was to peck the image of a target projected onto plates in front of them. A 3-bird system was used to increase the guidance system's reliability. If one pigeon failed to perform correctly and produced an erroneous signal, the other 2 could override it. The guidance system was divided into 3 sections: the light collector assembly, the viewplate assembly, and the chamber section. Mounted at the tip of the nose cone, the light collector assembly projected the image of the target to a screen in front of the pigeons. It consisted of a circular faceplate with 3 apertures arranged in a triangular pattern, each fitted with a lens. Behind each aperture was a periscope-like optical unit. To protect the optics from debris during flight, the entire assembly was enclosed beneath an oval plastic cover. The viewplate assembly consisted of 3 screens, 1 for each pigeon. They were also arranged in a triangular pattern to align with the periscope mirrors. Each screen was a translucent circular plastic disc mounted on 4 pressure springs. 4 air valves were positioned at each edge of the screen. These valves were linked by a network of air tubes to 4 manifolds, 1 for each direction of movement. Located behind the screens, the chamber section occupied most of the nose cone. Constructed from light sheet metal, it was pressurized and divided into 3 compartments, 1 for each pigeon. Each compartment had an access opening through which a bird could be inserted. Inside, the pigeons were secured in harnesses positioned directly in front of the screens displaying the target image. Their legs and wings were restrained, leaving only the head free to move. This minimized the risk of accidental contact with the control surfaces and ensured consistent, deliberate responses. The main explosive payload of the Pigeon bomb was a 325-pound Mark 17 depth charge. It was housed within the center section of the glider's fuselage, below the flight control system. The payload was powerful enough to severely damage or sink small and medium-sized vessels. The Pigeon bomb was designed to be carried on a wing rack of a Lockheed PV-1 Ventura patrol aircraft. Once released, the bomb descended on a controlled glide towards the target. The nose cone optical system continuously projected the target image onto the screens in front of the pigeons. Trained to recognize the image, the pigeons began pecking. Each contact with the screen was converted into pneumatic signals, allowing the control system to adjust the bomb's flight path. The Pigeon bomb's flight control system consisted of outlet air tubes leading from the guidance system's 4 manifolds to 2 pneumatic diaphragm units. To function properly, this pneumatic system required a constant vacuum, generated by 2 Venturi cones mounted externally on either side of the fuselage. 2 gyroscope units positioned right behind the diaphragms acted as a stabilizing element. It turned the pigeons pecking into smooth, proportional control signals, resisting sudden movements so the bomb could roll or pitch precisely without violent swings. At the rear of the fuselage was a battery pack, which supplied power to the servo unit assembly mounted in the upper section of the fuselage, directly beneath the wing assembly. As long as the glider remained on course, the image was projected onto the center of the screen. In this state, the pigeon's pecking caused equal vibrations coming from the screen in all directions. All 4 valves admitted balanced airflow, keeping the diaphragm units in neutral alignment. If the bomb drifted off course due to wind or some other factor, the target image shifted off the center of the screen. The pigeons continued to peck the image, but this time it resulted in an unequal vibration of the screen. This caused the valve nearest to the point of pecking to admit more air, while the opposite valve closed. More air flowed into one side of the diaphragm than the other, raising the pressure on that side. That sent a signal to a servo motor to move control rods attached to the elevons. At the same time, the gyroscope panel overbalanced. Once the course was corrected, the switch lever returned to neutral. The image on the screen returned back to center. The system allowed the pigeons to keep the weapon on a steady course until it struck the target. Even with all precautionary measures in place, the bomb's guidance system had one natural weakness. If weather conditions worsened, the projected target image lost clarity, causing the pigeons to peck the plates chaotically or even stop pecking altogether. The bomb would then drift too far off course, defeated by a rain cloud. This is the Bat Bomb, officially known as Project X-Ray. It was an experimental incendiary weapon developed by the United States during World War II. It relied upon the natural instincts of bats and was designed to set Japanese industrial complexes on fire. The Bat Bomb had the outside structure of a conventional aerial bomb. It was composed from 3 main sections: the body, the tail, and the explosive payload, with up to 1,040 tightly packed bats. The bats used to fill the compartments were Mexican free-tailed bats. They were chosen for the ability to enter a state of torpor. When subjected to low temperatures, they became dormant and could be stored in trays and transported without food or water. Once warmed, they revived quickly and took flight. The body of the bomb was a cylindrical container with straight vertical sides and a cone-shaped bottom. The container measured 5 feet in length. It was made from sheet metal and had walls perforated with small holes for air circulation to keep the bats alive during flight. The container of the prototype we recreated was packed with 26 trays stacked vertically, each 30 inches in diameter. Each tray resembled an egg carton and contained 31 compartments, one for each bat. The trays were secured to each other by short strings at the edges, with open sides facing down. Each bat packed inside the bomb was armed with an incendiary device. A 0.6-ounce napalm-filled cellulose capsule was personally designed by Dr. Louis Fieser, the inventor of napalm. Napalm was made from aluminium naphthenate and aluminium palmitate mixed with gasoline. It proved to be especially effective inside the wooden structures common in Japan during World War II. The capsule was glued directly to the bat's fur. The bats were placed freely inside the compartments, with the ignition trigger from an incendiary capsule on their chest tied to the compartment wall. To wake bats from their state of torpor, a heater system was installed inside the container. The tail assembly housed a parachute and an automatic mechanism for releasing the bats and deploying the parachute. On the outside, the tail assembly was fitted with 4 side vanes and a cylindrical central vane. They funneled and accelerated the air into the 4-bladed arming propeller at the top of the bomb, ensuring its rotation. The propeller was linked to an aircraft altimeter, responsible for activating and deploying the mechanism at a set altitude. The bomb was delivered to the target area by a B-25 Mitchell medium bomber. After release, it initially fell like an ordinary bomb. Tail vanes guided it down in vertical descent. Meanwhile, the warming unit increased the container's temperature to rouse the bats from their sleep. At 4,000 feet, an optimal altitude for the bats to reach the targets, the altimeter signaled a parachute to deploy, while simultaneously activating a mechanism that split the seams on opposite sides of the container, jettisoning the shell. The trays dropped to the ends of their strings, forming a column roughly 8.5 feet long beneath the parachute. As the trays spread, each bat would slide from its upside-down compartment onto the top of the tray below, which then became its launching platform. At the same time, short strings connecting the triggers to the compartment walls were pulled out, activating the time delay mechanism of the ignition trigger. The bats swung down through the air on a stable platform and orientated themselves before taking flight. The light made the bats quickly seek shelter. Rafters in wooden factories and hangars proved ideal hiding spots. After they'd found a proper hiding place, the bats calmed down, making them hard to spot. The ignition trigger was a mechanical delay pencil-type detonator, tiny enough to fit in the incendiary capsule. Inside the detonator was a striker held in place by a thin wire. Once triggered, the wire was slowly corroded by a copper chloride solution. Once the wire weakened enough, it broke, releasing the striker. The striker's sharp needle point was then driven forward by spring pressure and hit a specially made match head. The match lit instantly, also igniting the incendiary capsule. The ignition produced a 10-inch flame that would burn for about 4 minutes. Given the widespread use of wood in Japanese construction, even a single device was capable of setting an industrial-sized hall ablaze. A twin-engine B-25 had capacity for 25 bombs, delivering more than 20,000 bats in total. But the unpredictable behavior of the animals produced too many variables. Bats were not able to be guided to specific targets. At Carlsbad testing ground, armed bats set fire to friendly assets, including a hangar and a fuel tank. Unconventional designs and prototypes rarely saw combat, but one animal-borne explosive device came close to serial production due to a severe shortage of better alternatives. This is the anti-tank dog. The Soviets called it Собака Истребитель Tankov, ironically abbreviated to SIT. Used by the Soviet Army during the Second World War, it was a desperate attempt to stop German tanks at all costs. The 1st Battalion of Special Service Dogs was formed in 1941 and consisted of 212 trained animals. In this part of the film, we'll break down the 1943 standardized battle-tested explosive device known as the anti-tank mobile mine. The mine was designed as a canvas dog pack with 2 side bags containing TNT and a central wooden board with a trigger device. The total explosive load was 27.3 pounds, equivalent to approximately 2 German heavy Telemine 35 anti-tank mines. The trigger device was housed in a metal box riveted to a board positioned on the dog's back. The box had a hinged lid and featured 2 compartments. A 0.9 pound primary charge was placed in one of the compartments. 2 explosive-filled cords with detonating caps connected the trigger device to the side bags. The second compartment was used to mount the detonation system and hold an MUV pencil-type detonator. The handler would carry the detonator until such time as the dog was to be deployed. The target sensor of the bomb was a spring-loaded wooden lever, approximately 7.9 inches tall. It was connected to a rotating curved metal tooth with a safety pin that prevented accidental detonation. Once loaded, the whole pack weighed approximately 40.6 pounds. Different dog breeds were trained and used in combat, but German Shepherds were the preferred choice to carry the device. They were large enough to carry the mine pack and responded well to training. To ensure dogs attacked moving tanks, the handlers relied on a basic food reflex during training. Dogs were fed exclusively under stationary tanks, then under tanks with running engines, and finally under tanks that were moving and firing. The goal was to condition the dog to associate the space under a tank with food. In frontline conditions, managing regular training with actual tanks was difficult, and the dogs quickly lost their skills, resulting in numerous failures. During defensive operations, the Soviets employed special foxholes dug along routes where enemy tanks were expected to advance. Each foxhole was about 6 feet 7 inches deep and placed in a staggered checkerboard pattern. The distance between foxholes was typically 250 feet to 328 feet. The foxholes were designed to hide both the dog and its handler while allowing quick release. Inside the position there was a raised step. The handler stood on this step to watch for approaching tanks. To the handler's left was a recessed area for the dog, where it waited out of sight. From this resting area, a short earthen ramp led towards the enemy tank route. The ramp was about 5 feet long and angled at roughly 25 degrees, allowing the dog to accelerate quickly while still remaining hidden until the last moment. Once enemy tanks were spotted, the handler armed the explosive device carried by the dog. This meant inserting the detonator and preparing the trigger mechanism. When a tank moved within the engagement distance, the handler pulled out the safety pin, turning the dog into a live explosive. The dog then sprinted towards the tank at speeds of up to 9 miles an hour and dived under the front of the vehicle. When the dog passed beneath the tank, the trigger mechanism pressed against the tank's underside. This pressure released the firing pin inside the detonator. The detonator ignited an MD2 igniter, which in turn set off the TNT charge. The explosion struck the tank's relatively thin bottom armor, often rupturing it, killing or injuring the crew, starting fires inside the vehicle, and sometimes detonating onboard ammunition. It did not work perfectly. Using this crude system during a real-life battle frequently resulted in disaster. Some dogs panicked under artillery fire, attempting to jump back into the Soviet trenches with armed explosives. Also, as dogs were trained exclusively on Soviet tanks, no Soviet tanks could be used on the same battlefield as the anti-tank dogs in case of accidental detonation. Using dogs as anti-tank weapons was not popular with soldiers. It lowered personnel morale and was considered butchery. The horrific and cruel use of animals as weapons during World War II was not a success. Animals trained for more valuable roles, such as mine detection, transportation, communication, and rescue, were much more effective. For another terrifying weapon, watch our video on the Tsar Bomba, the largest bomb ever detonated.